begin talking about compounds, mixtures, and reactions. So here in part 1, we're going to talk about first, what is a pure substance? Pure substance is going to be a classification of matter that includes both elements and compounds. And when we talk about pure substances, we're talking about something that cannot be separated by any kind of physical means. Things like distilling or filtration. We could put sifting in there, picking out, any way that we could do it physically. We can't do that when we talk about pure substance. So elements, we've already studied in depth. We know what those are, so just kind of a review. They are all going to be made of just one type of atom. And they're all found on the periodic table. We know that really well now. So what is a compound? A compound then is going to be a pure substance that's created by two or more elements when they're chemically react and they join together. Some compounds that you might have heard of. Salt, we've talked about that already. H2O or water, CO2, carbon dioxide. NH3 is ammonia, and a couple of others that we'll learn about further as we talk more about compounds. All of these can combine in a whole lot of different ways. All these different things that you use in your life, these different substances, are made up of compounds. We can have hydrogen and oxygen combine in a couple of different ways. Carbon and oxygen can combine in different ways. So why do they form? Well, they basically form to become more stable. Sodium alone is very flammable. Chlorine alone is a very toxic substance. But when we put them together, they become that very stable element of table salt. It's not flammable, it's not toxic when you're using it in normal quantities. Compounds that are extremely unstable, if you have something that's unstable, it can break down to create elements that are much more stable. So how do they form? They form by the interaction of the nuclei and the valence electrons, those electrons in the outer shell when you have two or more elements. So let's talk about the octet rule. An element is going to be most stable when there are eight valence electrons, and I've talked about that already, so this shouldn't be new. So they're going to join chemically to get 8 valence electrons. For example, carbon dioxide. Oxygen has 6 valence electrons, and carbon has 4. We want to make 8, or some kind of multiple of 8. So when we join them together to get CO2, we end up with 8 valence electrons in each of those. So why do compounds have to do with your life? They're the substances that make up all living and non-living things. For example, where would we be without things like water, salt, rubbing alcohol? This particular one is a type of unsaturated fat, things that we need in our everyday lives. And what then is a mixture? Well, a mixture is going to be a physical combination of two or more substances. It's important to understand that a mixture is not chemically combined at all. And they can be separated by these physical means like distillation and filtration and sifting and picking out, chromatography. All of those can separate mixtures. They can be divided into two groups. We have homogeneous mixtures and heterogeneous mixtures. How do they form? They form by basically physically putting two things together, junking them together, throwing them together. Remember, no chemical change is occurring. We haven't changed this identity of any of these substances. And it's not the result of lowering any energy, taking energy away from it. So what is a homogeneous mixture? It's going to be a mixture that's evenly distributed. Homogeneous mixtures are usually called solutions. And with a solution, we have two parts. We have a solute and a solvent. Solute is going to be the stuff that's being dissolved. If you make Kool-Aid, the Kool-Aid is the solute. The solvent is whatever's doing the dissolving. So again, in our Kool-Aid, water is the solvent. The solvent is always going to be present in a greater quantity. There's a whole lot more water than there is Kool-Aid. The solute then is present in a lesser quantity. That's just what that's explaining. I'm going to have a whole lot more water in something than I am the salt or the Kool-Aid or whatever it is I'm mixing into the water. However, it all becomes evenly distributed throughout the solution. So then what is a heterogeneous mixture? This mixture is a mixture that's unevenly distributed. If you think about iced tea, you put ice in your tea. Ice floats to the top. It's not evenly distributed throughout the glass. So therefore, it's not a homogeneous mixture. Or if we have Chex Mix, you reach your hand in and you grab out a handful of Chex Mix. You are not going to get the exact same amount of every part that's in Chex Mix. It's not a homogeneous mixture. It's not evenly distributed. It's unevenly distributed, so it becomes a heterogeneous mixture. So how are mixtures important in your life? You encounter mixtures everywhere in your life, all kinds of places. Where would we be without things like ice cream? How about Kool-Aid? Shampoo, soup, milk. I can go on and on and on. These are all different types of mixtures, and they're things that we encounter all of the time.